Right. Then shall we go for that application of derivatives first, right? Then in our next session, right, after the break, right, we can start equilibrium of a particle, right? Okay, then write down the topic, application of derivatives. Application of derivatives. Application of derivatives. Indura, can you hear me?
Yes, sir.
Any difference?
Sir, the room is lighter.
What is lighter?
Okay, not sir, lighter. Earlier, sir. So English we can
මොනටද?
Oh, sir.
ඒක කලින්ට වඩා හොඳයිද නරකයිද?
Our nice.
දැන් පේනවා නේ. right. මම කලුම නෑ කියලා හරි. මේ ස්ක්‍රීන් වල ලවුඩින් කරන්න ප්‍රශ්න වෙලා තියෙන්නේ හරි. නෑ මේ මම අනිත් ලැප්ටොප්ස් දෙකම පොඩ්ඩක් සර්විස් එකකට එක්කෙනෙක් ගෙන්නලා සර්විස් කරනවා හරි. මම අර අලුත් HP එකක් ගත්තා. තව අනිත් වැඩවලට හරි. දැනට සපෝටිව් ඒක ජොයින් කරගා. ඒකෙත් තමයි කරන්නේ. හරි. මම මේ කැම් එක සෙට් කරද්දී මුලින්ම ටිකක් එකපාරටම ඩාර්ක් වැඩි හින්දා මම ඊට පස්සේ පොඩි සෙටින්ග්ස් බලනකොට හදලා ගත්තාම මෙහෙම දෙයක් වුණා වගේ පේනවා. හරි. right. මම සුදු නෑ මම කළුත් නෑ. හරි. right. Anyway, then we can go for that application of derivatives, right? Right. So you know that we discussed that all the differentiation techniques, right? X to the power n, right? Then we discussed trigonometric functions and their differentiation, right? And then we discuss exponential functions. Then we move to that inverse functions, especially inverse and logarithmic functions, right? Then after that, we discuss implicit derivatives, right? Then we move to that second order derivative. And not only that, we use that multiplication, that is product rule and quotient rule. Earlier we discussed chain rule, right? Then we move to that second order derivative, right? And finally we move to that parametric derivatives. Clear, right? So this is the basic content that we have in our syllabus, right? Anyway, in our syllabus means actually, you know that when you do engineering, right, lots of things, right, will be with calculus, that means differentiation and integration. Clear, right? So therefore, this is one important part, right? Right. Now, when we go for that application of derivatives, right, then you have to understand, right, the definitions that what we directed to the applications, right? If someone asks, right, what is differentiation, right? If someone asks what is differentiation, what should be your answer? What should be your answer, Sarah? If someone asks what is differentiation, what should be your answer? What should be your answer? Tell me. Let me cut you with Mike's problem. Yes, right. Finding the gradient function of a function given, right? That what if someone asks, you can say, right, the gradient, yeah, try the gradient of the tangent to the curve, right? That also okay, but the best thing is finding the gradient function to a function given. Clear, right? So this is a simple idea. And now understand that especially in this differentiation, right? when we go for that application, right, there are few parts, right? One is especially finding the tangent and normal to a curve given, clear, right? And not only that, then we find the equation of the tangent and normal to a curve given, clear, right? That is that part, right? And then we are moving to that sketching curves, increase and decrease in functions and sketching curves, right? So that means actually when you are given any algebraic function, we can go for their graphs, right? We can draw any graph, right? And I will explain, and not only that, right? There are lots of sub applications, right? Transformations again has to be applied, right? So there's a lot to discuss under the curve sketching, right? Then we are moving to, right, the real life applications. The real life applications means especially minimizing, maximizing problems, especially that is called minimizing, maximizing, generally called optimization, clear, right? We are discussing that problems under optimization, right? And finally, we are talking about that actually the rate of change, problems involved in rate of change, clear, right? So this is the content that we have to discuss, right? Okay, then first let's discuss few questions generally, and then we can go for especially the gradient of the tangent and normal. Okay, right now you know that when we go for that application, right, I will take a function, right, y equals x cube plus 1. Here y equals x cube plus 1, right? Now you know that what is the graphical shape, right? Can you remember? X cube graph, right? The x cube graph like this one, clear, right? X cube plus 1 means actually 1 unit up, right? Then anyway, right? If you take dy by dx, what is dy by dx here? 3x squared, right? So you know that this is the gradient function, clear? Dy by dx equals 3x squared. 3x squared is the gradient function, right? Okay, now if I ask, right, dy by dx, right, at x equals 0, right, then what do we do actually? 3 into 0 squared anyway 0, right? Then dy by dx, right, at x equals 1, right? At x equals 1, actually 3 into 1 squared anyway 3, right? And dy by dx, right, at x equals minus 1, again 3, because minus 1 squared is plus 1 into 3, 3, clear? So this is how we can take the gradient, clear? Now, you know what does it mean? I explained earlier also by using one example, right? Here 0, right? Usually the curve of that y equals x cube plus 1 like this, right? Now, you know that at x equals 0, the gradient is 0. What does it mean? When you draw the tangent, it will be like this. Here, here the gradient is 0. Okay. Then, when you go for that gradient at x equals 1, right? Then it will be a line like this. Okay. Now, this line has the gradient 3. Okay. And if you draw a line at x equals minus 1, right? Minus right? Now suppose that the tangent is here, right? Like this, then gradient equals to this, right? You know that when y equals 0, x cube equals 1, right? X cube equals 1 minus 1 means, right? You know that x cube equals minus 1 cube, right? So x equals minus 1, exactly on the x-axis, right? So these are the things that can be seen here, right? Right. Then we can find out the gradient at any x value given. Clear? Okay, now write down. Consider the function, right? Under that first example, consider the function y equals x cube plus 1, right? Consider the function y equals x cube plus 1. Consider the function y equals x cube plus 1. Then write down. Let us find the gradient of the tangent. Let us find the gradient of the tangent. Let us find the gradient of the tangent. Let us find the gradient of the tangent to the curve at x equals -1, x equals 0, and x equals 1, right? Let us find the gradient of the tangent to the curve at x equals -1 and x equals 0 and x equals 1, right? Okay, then take the function, take the gradient function, and take these gradients. Finally, mark them on the graph, right? Now, this is additionally for you, right? And I will give you a paper tomorrow, right? Now, please answer for them, right? And then I will let you know the discussion time, right? තාම අපිට Tuesday පොඩි issue එකක් තියෙනවා සමහර ළමයින්ට. Mohammad Lukman, are you a newcomer?
No, sir.
Then what is your problem here? You don't know how to find out the gradient function? Lukman, did you participate for the differentiation? Then you don't understand this part? Okay, right. X cube plus 1 graph, right, was this given early, right? Now, even we can manage these graphs also, right? After the discussion of the curve sketching, right? Up to now, right? X cube plus 1 graph is like this. Just take the graph, right? Right? Don't worry about the graph, right? Graph, any function will be, right, drawn after the discussion of that sketching curve, right? Now the graph is like this. I just told you, just take it, right? We later we can discuss how to take the graph of these functions, right? Now here I just wanted to mention how do we take the gradients, right, to the curve at different x values, right? Right. Okay. Now, algebraically, we know how to take the gradient of any function. Clear? Right. Okay. Now, please go to the tute. Right. In the tute, we can go for this page number 15. Right. Go to the page number 15. In the page number 15, right. Find the gradient for the curves of the function at the points given. Right. Actually, points means x values given, right? So you can see that in the first part, right? the first function is y equals 1 over x. So we want to find out the gradient of this curve, right? What is that problem? Milane, එහෙනම් අඩුයි සද්දේ?
ඔව් සර් අඩුවෙන් ඇහෙන්නේ සර් කලින් වගේ නෙමෙයි.
දැන් කොහමද?
තාම ඒ වගේ තමයි.
පොඩ්ඩයි. right. දැන් බලන්න. ලසිනි දැන් කොහමද?
සර් දැන් කලින්ට වඩා පොඩ්ඩක් වැඩියෙන් ඇහෙනවා.
Yes. පළවෙනි සිද්ධිය තමයි දැන් මේ ඉස්සෙල්ලාම දැන්නේ මම මේක යූස් කරේ. right. ඉස්සෙල්ලාට වඩා ටිකක් ඇහෙනවද?
ඔව් සර්.
Mohammed, what about you? Can you hear me clearly now?
Yes, sir.
yes sir.
right. හරි මොනවාද දෙයක් තිබුණා මට please message එකක් දාන්න මේ අර අනිත් laptop එක පොඩ්ඩක් ඒක නැත්නම් මම SSD එකක් දාගත්තා වෙනම මේ තවත් ටිකක් ස්පීඩ් එක හදාගන්න ඕනේ නේද හරි ඒ වැඩ ටික ඉවරනකම් තමයි මම මේ laptop එක use කරන්නේ right okay then now you know that the simple idea right when you go for that y equals 1 over x. So you can rearrange it as x to the power minus 1. Then when you go for the gradient function, you will be having minus 1 x to the power minus 2, right? That means actually minus 1 over x squared, right? So we want to find out the gradient, right? We want to find out the gradient at x equals 3, right? So therefore, dy by dx at x equals 3, right? At x equals 3 means actually minus 1 over 3 square, right? So minus 1 over 9. This is the gradient. Did you get the mechanism? Right? It's a very simple question. Right? What you have to find? You are given the function. You want to find out the gradient function. And then you have to substitute the x value given. Right? Then you can take the exact gradient at that x value given. Right? Okay, now please copy down the first part. Right, this is the first question under the application of the derivatives in the page number 15, right? Page number 15, okay? Right, then similarly, shall we take this also? Please mark the fourth, the fifth part, and the seventh part, and the 10th part and the 12th part, right? These are the 4 parts should be done by this idea, right? Now in the fifth part, actually, you have the function, right? X minus 3 into x plus 4, right? You have to find out the gradient at x equals minus 1. Okay. The best thing, you can differentiate this one, right? Actually, by the product rule, x minus 3 into 1 plus x plus 4 into 1, right? That means you will be having 2x plus 1. See, very simple, right? Then dy by dx, right? At x equals minus 1, right? Understand the meaning of this symbol, right? Gradient at x equals minus 1, okay? So you get 2 into minus 1 plus 1. The answer is minus 2, okay? Okay, now similarly, we can take 7, 10, and 12. 7, 10, and 12.
Muted.
Right, okay. Now, see, it's a very simple case, right? Now, raise your hand those who have done the seventh part. Seventh part. Abhidam, what is the value? What is the gradient?
So root 2 over 4.
You know that for the seventh one, right? So y equals square root of x. Then you know that dy by dx equals 1 over 2 root x, right? Then dy by dx at x equals 2, right? Yes. 1 over 2 root 2, right? Root 2 over 4, right? Yeah, good that rationalizing denominator also, right? Root 2 over 4. Now in the 10th one, right? Actually, in the 10th one, you don't need to go for the product rule, right? You better rearrange like this. 2 root x and minus 2x. Clear? If you could rearrange like this, then dy by dx equals, right? 2 into 1 over 2 root x minus 2, right? And these two cancel. Then dy by dx at x equals 4, right? That means 1 over root 4 minus 2, right? Then minus 3 over 2, right? Over minus 3 over 2. Right, okay, good. Then the 12th one. The 12th one, you are given the function y equals root x minus 1 over root x, right? Raise your hand those who have done this. And x equals 9. Now, this is the ratio of two functions, clear? Although you have a ratio of two functions, we don't need to go for the quotient rule, clear? Right, make a simple case. You better rewrite like this. See, when you divide root x by root x 1, then minus 1 over root x. Then actually we can write it as 1 minus x to the power minus half. See, you know that this is x to the power half, right? That means x to the power minus half, right? Then when you go for the differentiation, dy by dx equals their differentiation 0, then minus to minus plus half x to the power minus 3 over 2, right? Then dy by dx, right? And x equals 9 equals here half into 9 to the power 3 over 2 minus, right? That means 1 over 2 into 3 squared, right? These two cancel, 3 cube, then 1 over 54. Raise your hand, those who have taken that 1 over 54. Right, good. Then me quotient rule like apply करबो कट्टी मट गया. So once you apply the quotient rule, right? Anyway, right now you can see that this is bit short, right? Differentiate then minus, right? Differentiate divide by denominator squared, right? So then you can do it this way quickly, right? Right. Okay. Then we can go for another type, right? Actually, we discuss it one form like this type. Then this part that we are going to do is the opposite process actually, right? You are given, right? You are given the gradient. You have to find out the point corresponding to that gradient. Clear? Right? Write down this example. Find the point. Find the point. Find the point, sometimes points, okay? Find the points On the curve, find the points on the curve corresponding to the find the point on the curve corresponding to the gradients given. Corresponding to the gradients given. Find the points on the curve corresponding to the gradients given, right? Okay, now first one. Y equals, right? Y equals x squared minus x minus 2, right? In the gradient equals 2, right? Gradient equals 2. Right, now understand how do we get this, okay? You know that if you are given the function, we have to go for the gradient function, right? So what is the gradient function actually? 2x minus 1, clear? 2x minus 1. Now, we want to find out the x value corresponding to this gradient is 2 actually, right? That means, actually I write here dy by dx, right? At x equals a particular value a, right? At x equals a is 2x minus 1. Can you tell me when you substitute x by a, you get 2a minus 1, clear? Now, you know that this particular gradient is given as 2, clear? So therefore, we can write that 2a minus 1 equals 2, then a equals actually 3 over 2, clear? A equals 3 over 2. Now, we know that exact x value on the curve corresponding to this gradient is 2, right? Then how can you find out the y value, right? Therefore, right, y equals, right? Y equals, here we can write 3 over 2, whole thing squared, minus 3 over 2 and minus 2, right? That means actually you get here 9 over 4 minus 3 over 2 minus 1, right? Here. Then the common denominator is actually 4, then 9 minus 6 minus 8 divided by 4, right? So what the answer? Minus 5, right? Minus 5 over 4, right? Right? So you will be having a quadratic curve, right? Like this, x and y, right? Then there will be a graph like this, clear? Now, if you take, right? If you take a particular point here, and if you draw a tangent like this, right? Their gradient is 2, clear? Now this particular point only, what? 3 over 2, comma, minus 5 over 4, correct, no? X positive, y negative means in the fourth quadrant, right? Actually, that particular point on the fourth quadrant, right? This is the curve of y equals x squared minus x minus 2, right? I just explained graphically one example. We don't need to understand each and every example graphically, right? But understand what we have done here, right? You are given the curve. We want to find out the coordinate corresponding to this gradient, right? Here the gradient is 2. We have only one particular tangent for this curve and for this gradient 2, right? Then the corresponding x value is 3 over 2 and y value is minus 5 over 4. How did you get this y value? You just substitute this x value to the curve, right? Then මෙහෙමයි ළමයි. මෙන්න මෙතෙන්දී ඔයාලට ඕන මෙහෙම දෙයක් කරන්නත් පුළුවන්, right? Let 2x minus 1 equals 2, then x equals 3 over 2 කියලා කෙලින්ම x වලින් ඉවත් කමක් නැහැ, right? මේ A value එකක් කරගෙන A හොයන්න ඕනේ නැහැ. හරි? You can do in that way also. Clear? Right? Okay, now please take this part also. Right? First, take this first part. Right? And I'll discuss another example. Yes, Akash. In cubic functions, it can be different. I take one example. Okay, I'll take the second example, right? The function is y equals x squared minus 3x plus 4, right? Actually, some feel that this is a bit hard, right? Yeah, that's what, great, right? I know that your feelings, right? 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 So we want to find out the point, right? On the curve corresponding to the gradient, right? Minus 1, okay? We want to find out the point on the curve corresponding to gradient minus 1, right? Type clear? This one also same way like the previous example. Kavish, any problem?
Sorry, sir. Hand.
Okay, right. Right. Now, what is the problem here? Now, what is the special type of these questions? We are finding the point on the curve, right? Now, you know that this function has a curve, right? So we are finding the point on this particular curve corresponding to the gradient minus 1. Clear? How do we take that? You know that when you find the gradient function, dy by dx equals 2x minus 3. Clear? Now, suppose that we are going to find out that x value corresponding to the gradient minus 1, right? Earlier, we are given the x value and we found the gradient. Okay. Now, what do we do that? Okay, you just equate 2x minus 3 to this minus 1. Clear? Then 2x minus 3 equals minus 1 means this goes to other side, then becomes 2 and divided by 2, x equals 1. Understand, you know that this is a quadratic curve, right? It's a parabola, right? In this parabola, there's a point on this parabola corresponding to the gradient minus 1. Their x coordinate is 1. That's what we found. Clear? Right? And I think you participated to that basic coordinate geometry also, right? Coordinate geometry descriptive discuss right? Then you know that we want to find out the x value corresponding to this y value corresponding to this x equals 1, right? Therefore, y equals, you substitute here, right? 1 squared minus 3 into 1 plus 4, right? The answer is 2. Clear? Then, okay, you just name the point by a letter, right? You can put any letter here, right? I put A, they are coordinate actually 1, right? That's how we get the gradient. Okay. But the point A is right 1, 2, right? Okay, now please take the second part also. Now I think something okay, right? Is the second example. Then we want the third example actually. Y equals, right? X cube. Y equals x cube for the first gradient actually. 12, right? The second gradient is 3. Third gradient equals minus 3. And the fourth gradient equals minus 2. Okay. Now, third question example, something like 4 questions. Okay. We want to find out the points on the curve corresponding to these gradients. Yeah, right? Sir, it means if we have a power 4 function, we will have 3 points. Yeah, maybe mostly. Clear, right? Sometimes we are getting that coincident points. Clear, right? Maximum is 3, right?
Sir, mute now.
All right. Okay. Now I'm going to discuss the first subpart for this third example, right? First, you find the gradient function. Now you just equate this gradient function to the particular gradient given, right? 3x squared is equal to 12, right? Then dividing by 3, you get here 4. X squared equals 4 means x equals plus or minus 2, right? X equals plus or minus 2. See, now there are two tangents actually, right? There are two different tangents on the same curve for this gradient 12, right? That's a simple idea, right? Okay, now you know that when x equals plus 2, y equals, right? 2 cube is 8, right? When x equals minus 2, then y equals minus 2 cube, right? That means minus 8, right? Then you can define one point as A, which is 2, 8. The other point is B, which is minus 2, minus 8, right? 2, 8, and the other one is minus 2, minus 8, right? Those are the 2 points on the curve. See whether similarly, right? How many points you can take for the next 3 parts? Right, then in the second part, for the gradient m equals 3, right? Please raise your hand, those who have found points. Manet, what are the points?
The 1, 1.
1, 1. That's all.
-1, -1.
Yes, right. See whether you got 1, 1 and -1, -1, right? Those are the 2 points on the curve corresponding to the gradient 3, right? Then, for the third part, Salman Faisal, what are the points?
So no tangent to the curve with gradient minus.
Very good, right? Now see whether, right? No points on the curve for this gradient -3, right? Then similarly, you will be having for the fourth part also, no points on the curve corresponding to the gradient -2 also, because you know that when you equate this 3x squared to -2, then x squared equals -2 or 3. When you get the square root, you get imaginary numbers, right? That means we have no gradients. Why is that, right? Why is that? Now, if you can remember, I explained the x cube plus 1 graph, right? Then what is the x cube graph? It will be like this, okay? Now you can see that actually here, right? Just touch this curve, right? Touch the one, right? When you touch this curve by a tangent, right? Just move a tangent on the curve. Now can you see that all the tangents, right, make an acute angle or 0, here 0. By all the other points, you can make an acute angle, right? If it is an acute angle, what is the tan ratio of an acute angle? That means I'm asking, what is the sign of the tan ratio of an acute angle? It's always plus, right? Abhiram, can you hear me?
Yes, sir, I can hear you.
Right, okay. Then right, okay. Then what I was talking, right? Now you can see that here for these two gradients, right? These two gradients, we have no points on the curve because all the gradients, right, on this curve are positive, and here it is 0, right? Then what does mean that positive gradients? You can see that whatever tangent to the curve makes an acute angle with the positive side of the x-axis, right? Acute angle means the first quadrant's tan ratio is positive. You know that gradient is given by the tan ratio of this angle. Clear? That's why we get positive gradients always, right? Kavish, did you understand?
Yes, sir.
Okay. Chandiru, did you understand?
Yes, sir.
Right. Okay. Now, I think you all understood that, right? I just selected some names randomly. What about you? Pantuli, got it? Did you understand? Right. Okay. Now, this is the simple idea. Okay. Right. Now, in the tute, right? In the tute, you can mark these all the questions, right? That all are same way like display, right? Mark that page number 15, first question all, right? And second question all, right? Second question all. Now, shall we get this answer? Second question, sixth part, right? Second question, sixth part. Second question, sixth part, right? X plus 1 over x with a gradient 2, right? Now, please tell me the points on the curve for this gradient. And there are a few more examples should be taken to our note, right? Examples, right? They also first one y equals e to the power x, e to the power x under that part A for m equals, right? For m equals e cube. Part B for the gradient one. Part C for the gradient three. Part D for the gradient minus one. The gradient zero. The second one, right? Y equals sine sine 2x. Then under part A, gradient is half. No, the gradient is 1. Part B, minus root 3. Now, see whether you are familiar with these exponentials or exponential functions, right? So the gradient function also ex, that's what you know, right? Okay, then you can equate ex e to the power 3. Therefore, the corresponding x value is 3, right? Why? Base cancel? No, right? For the reason, you know that's a one-to-one function, right? We have one x value for this gradient e to the power 3, right? Therefore, y equals, right? Y equals e to the power 3, right? Then you can take the point A, 3 comma e to the power 3. Evan api kochchar lucky the here. Right? The Excel syllabus again, never scientific calculator again done, right? We have right to the decimals, right? But here it's not needed like that, right? We can just mark that points like this. Then similarly for the gradient 3, how do we take the x value for the gradient? Let's gradient 1. I think that also will be okay. So you can equate e to the power x to the value 1. 1 means actually e to the power 0, right? Therefore, x equals 0, right? And then y equals the corresponding y value, right? You know that 1, right? Then you just name the point B, that will be 0, 1, right? Now just imagine that exponential graph, Ex curve. You know that this curve passes through 0, 1, right? At that time, the gradient of the curve is 1, right? Then for the part C, what do? We can equate that gradient function Ex to this gradient 3, right? If Ex equals 3, what is the x value? Please tell me, someone quickly. If e to the power x equals 3, please, what is the x value? Very good, Kiran. Okay, Savishka, Sarah. Right, okay, now I think you can remember. Ex is less than 3. Now here the gradient actually, right? අපි දන්නවා ex curve එක ගත්තාම හරි. දැන් මෙන්න මෙහෙම graph එකක් නේ. Now it's a particular graph like this, exponential growth, okay? Yx at this point, the gradient is 1, right? Then yeah, at x equals 3, gradient is e to the power 3, right? So something like I'm asking right now, suppose that the gradient, now when you draw this tangent, right? When you draw this tangent, suppose that its gradient is 3, we want to find out this x value, right? How do we do? Right, then on the logarithmic and exponential functions, right? So you know that if you have like this, you have to take ln of both the sides, right? Ln e to the power x equals ln3, right? So you know that ln is log to the base e, log to the base e, right? X ln e equals ln3, right? What is ln e? 1, right? So therefore x equals ln3. Okay? ln3 means log to the base e3, right? So that is the x value, right? Therefore, y equals e to the power ln3. Can someone tell me what is e to the power ln3? Please, quickly. What is that value of e to the power ln3? Idura? Very good, Sabit. Not 1. What does mean x? Yeah, I'm asking e to the power ln3. Yes, correct answer is coming. who is asking me this question mark, right? Question mark thing on the right? Now, if you want, right? So you know that again. Again, take they are ln, right? So you can see that ln y equals ln e to the power ln3. That means ln y equals ln3 ln e. What is ln e? ln e means log to the base e, right? 1. Then ln y equals ln3, right? Therefore, y equals 3. Clear? Therefore, the point is actually ln3, 3, right? You can just name the point C, right? The point C is actually ln3, 3, right? මේ ළමයි මේක අමතක කරන්න එපා හරි. සමහර ළමයි දැන් මේක හරියට කැච් කරගත්තේ නැත්නම් right? එතන 2016 or 17 or question එකක් 16 මම හරි. right? ඒක අග්ගල එකපාරට බැලන්ස් කරගන්න බැරිච්ච ළමයි ගොඩක් තියෙනවා. හරි. right? You know that e to the power ln x, right? E to the power, right? ln a is always a, right? Make a please highlight color correctly. Right? I have given this earlier also. E to the power ln a is a, right? That's how we get it, right? Okay. Similarly, please answer for these also, right? For this gradient -1, for this gradient 0. And similarly, I think this will be okay, right? For the sine 2x under the gradient 1 and -√3, right? Right. Raise your hand those who have taken the answer for the part D. Okay, Sarah, what is the answer?
No solution.
Yeah. The X value is not real, right? The X value is not real. Because you know that here also, right? This has a positive gradient always. How do you say algebraically? Now, if you equate, right? Let another part B e to the power x equals -1. Here, e to the power x equals -1. You know that ex equals -1 never exists because ex is always positive. Okay, right? How do we explain? Actually, you can understand further by graphical, right? Ex graph like this, right? This is y equals e to the power x, and this is y equals -1. Okay, the two graphs are not equal, right? For any real value of x, right? Now, this is for your knowledge, but understand, right? Now, I have given this early, right? In a element knowledge again. So you can write that x is not real, right? Therefore, x is not real, right? Otherwise, x equals ln -1, right? Or x equals ln -1. You know that here -1 does not exist, right? ඒකම තමයි මෙතන කියන්නේ. ඒ හින්දා මම මේකයි කිව්වේ මේක ඕනේ නැහැ. x is not real, right? X is not real, right? For the part E, raise your hand those who are done. E to the power x equals 0. Savishka, what is your answer?
X is not real.
They are also x is not real. X is not real. Ex equals 0 means, right? So you know that, see, Ex graph never touch the x-axis, right? Never touch the x-axis means, right? There's not a 0 value, right? Therefore, x is not real, right? Now, raise your hand those who have done the second question under the part A. Kavish, what is the answer?
So 5/6 √3/2.
5/6.
X equals 5/6.
X equals 5/6. Sure.
Yes, sir.
Okay, then for the second one, right? You know that the gradient function, right? The gradient function is sin 2x means 2 cos 2x, right? 2 cos 2x. Then under the part A, you can equate, right? 2 cos 2x to the value 1, right? So therefore cos 2x equals half, right? Then cos 2x equals cos pi/3. Then x2, okay, 2x equals, right? I put a done to the 2n pi plus or minus pi by 3 here.
ඒ ඔක්කොම ගන්නවා.
ඇයි බං ඉතින් මේක කියලා නැහැ මම කොහෙවත් ලිමිට් කරන්න කියලා. මම කොහෙද කියලා මේක ලිමිට් කරන්න කියලා. Right, you are given the domain of the function from 0 to pi by 2 එහෙම කියලා දිනනවා. නැහැ. Right. Now just imagine that sine curve, right? So you know that in sine curve, then finally you can take x values, right? Therefore x equals n pi plus or minus, right? N pi plus or minus pi by 6, where n is any integer. There are infinity x values, right? Yes, see here, right? I will share you this most graph. Let me balance. Yeah, right. So you can see that here. This is the sine curve, right? So gradient එක අපි ගත්තොත් එහෙම gradient is 1, right? Gradient is 1 means if you draw a tangent, right? 1 will be at here, right? Okay. When you put n equals 0 at plus pi by 6, again, right? Then you get one gradient like this, right? At minus pi by 6 also another gradient like this, right? Then when you put n equals 1, pi plus pi by 6, right? Then pi plus pi by 6. And may have it, pi minus pi by 6. And may have it, right? So something like that. There are infinity, right? See, right? That took me pain on, right? Right? Clear? That means there are infinity tangents. Clear, right? So that's what explained by, right? This x equals n pi plus or minus pi by 6. Clear? Okay, now similarly, right? How do we get the answer for the part B? Raise your hand over there for the part B.
So then for y values, we can't define the number of y values, right?
Yeah. Lot of points define කරන්න පුළුවන්, right? For value by value, we have to take that infinity points. Right? Anyway, then write down after this, there are infinity points. Okay? There are infinity points, right? Then we can't take exact, we can't take all the coordinates. We can take, right, some coordinates. Then enter 0 දාපුවාම plus pi by 6 or method substitute කරනවා, right? Here. Then you get sine pi by 3, right? That means root 3 over 2. One is pi by 6 comma root 3 over 2. Other one is minus pi by 6 comma minus root 3 over 2. Where the other, right? Coordinates right. For the part B, what are the x values? What are the x values correspond to that? Where is minus root 3? Please let me know. Raise your hand also on this for the part B. පේනවනේ differentiation ඇතුළේ trigonometry. හරි. එතන අපිට එක chapter එකක්වත් නැතුව වැඩ කරන්න බෑ. හරි. හැම එකක්ම ඕන. හරි. Okay, then what do we do? You just equate let 2 cos 2x. 2 cos 2x equals, right? Minus root 3. Then cos 2x equals minus root 3 or 2, right? That means you can write cos 2x equals minus cos pi by 6, right? Minus cos pi by 6. How do you eliminate this minus? Rahul, how do you eliminate this minus? Rahul, are you there? Tulit, tell me, how do we eliminate minus? Tulit, මොකද ඉතින් අන්තිම නම දාගන්නේ? Okay, Charita, tell me.
So take the angle in the second quadrant, so it becomes cos pi minus pi by 6.
Very good. Pi minus pi by 6. That means 5 pi by 6. Therefore, 2x equals 2n pi plus or minus 5 pi by 6. That means x equals n pi plus or minus 5 pi by 12. Right? Where n is any integer. Right? Again, you can say there are infinity points on the curve for this gradient minus root 3. There are infinity points on the curve for the gradient minus root 3. Right. Okay. Then we can go for another subtopic. Write down increasing and decreasing functions. 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 Then we burn, right? Actually, now it's very easy because of this response calculator, right? Luchita, what do you see? Kavish, you can see the graph, right?
Yes, sir.
All right, now see, you know that, right? Now, if I come like this, actually, here. Now you can see that in this range, if I started from this actually minus 12, okay, right? The function is increasing because why? Tangent makes an acute angle with the x-axis. Imagine this is the x-axis, no? This angle is acute, right? Therefore, the function is increasing, right? Because you suppose that you started from negative infinity on the right? Right? Then I came up to minus 12, right? After minus 12 also, when you increase the x values, the y values are also increasing, right? So it comes to a particular maximum value here, right? In that case, at this point, right, what can you see? Actually, the gradient is, right? Metin, you know that this is a horizontal line. The horizontal line is gradient is 0, right? Gradient is 0. Then after that, what happened? You can see that this line makes an obtuse angle. Can you see here, right? Actually, here to there, obtuse angle, right? Obtuse angle means their tan ratio is actually negative, right? So that means function is decreasing. Can you see here, right? Now, when it comes to this point, actually the graph is horizontal just for a while, again increasing, right? Again increasing means acute angle, right? Then here horizontal, right? Therefore, you can see that actually the function has a 0 gradient, right? Again decreasing. This is what you can see, right? Now, what does it mean? Very simple. If a function is increasing, its dy by dx is positive. If a function is decreasing, its dy by dx is negative. If a function is actually called stationary, stationary means, right, just for a while, the tangent is horizontal, right? If the function is stationary, right, then dy by dx equals 0. Clear? This is what you can see, right? Okay, now, find out, consider a function y equals fx. Consider a function y equals fx for x from a to x equals a to x equals b as follows. From x equals a to x equals b as follows. I take this value as b, right? And this as a. Okay. I take this as another value, right? And please draw a tangent in this range. Now, this is a common property for any function, right? Consider a function y equals fx from x equals a to x equals b as follows, right? Then take the three tangents. Actually, if you want, you can use different colors, right? And understand here, c is a value between a and b, right? Where c is a value between a and b. Right. Charita, finish?
Yes, sir.
Okay, then write down. According to the graph, according to the graph, according to the graph, according to the graph, okay, then take the first point. According to the graph, alpha is between 0 and pi by 2 for x actually greater than a and lesser than c, right? X greater than a and lesser than c. Alpha is an angle which is 0 between 0 and pi by 1, right? What is the median? But how do you understand this? Alpha is an acute angle, right? Therefore, tan alpha is positive. Therefore, tan alpha is positive for x from A to C, right? For x from A to C. That is, dy by dx is positive in that range because of dy by dx, right, equals tan alpha, right? In that range, dy by gradient or defined by tan alpha, okay? Dy by dx is positive, right, from A to C. Okay, then write down. Therefore, the function y equals fx. Therefore, the function y equals fx is increasing. Therefore, the function y equals fx is increasing for x from A to C. Therefore, the function y equals fx is increasing for x from A to C. Right? That means, how do you understand? Right? If you draw a tangent to the curve, if the tangent makes an acute angle, that means the function is increasing in that particular range. Clear? It's a simple idea, right? Okay, then write down here beta, right? Beta is actually between pi by 2 and pi, right? So x from C to D, C to D, okay? For x from C to D. Beta is an obtuse angle for the x values from C to D, right? See, in this whole range, you can have an obtuse angle, right? Therefore, tan beta is, what is the tan beta sign? You know that if it is an obtuse angle, tan beta is negative, right? For that particular range. Tan beta is negative. That means dy by dx is negative in that particular range, right? Dy by dx is negative. Okay, then write down. Therefore, the function y equals fx is decreasing. Therefore, the function y equals fx is decreasing. Therefore, the function y equals fx is decreasing in the range from x from c to b, right? In the range from x equals c to b, right? In the range x greater than c and lesser than b. Clear? That's what you can say, right? Okay, then put a stand right down next line. Dy by dx equals 0. Dy by dx equals 0 at x equals c. Dy by dx equals 0 at x equals c. And write down within bracket because of the tangent is horizontal. Because of the tangent is horizontal. Because of the tangent is horizontal. Then it is said to be, the graph has a stationary point. Then it is said to be, the graph has a stationary point at x equals c. The graph has a stationary point at x equals c. Then it is said to be, the graph has a stationary point at x equals c. Right, okay. I'll discuss some examples, right? Like a simple idea, right? First, write down. Find the range of values of x. 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 For the increasing and decreasing, find the range of values of x for the increasing and decreasing of the following functions. Find the range of values of x for the increasing and decreasing of the following functions. Make a simple idea. The example, right? I'll take this example, right? First one, y equals minus x squared plus 2, right? Y equals minus x squared plus 2. Can someone explain me quickly what type of graph is this? You know that it's a maximum parabola, right? It's a maximum parabola, right? Then, right? If you go for the differentiation, right? dy by dx equals minus 2x. Okay? dy by dx equals minus 2x. Now, shall we take that the x value for stationary point, right? Now, at stationary points, right? At stationary points, you know that dy by dx equals 0. Now, that means if you equate this minus 2x to 0, the corresponding x value is 0, right? X value is 0, right? Now, what do we do? Then actually, right, for the lesser than 0 and greater than 0, right? We can check what is the sign of dy by dx, right? Now, please tell me an integer value lesser than 0, Kavish.
-1.
If you put -1, right, here, what is the sign of the gradient?
So plus.
Plus. What does it mean? The function is increasing. Otherwise, you can say inverse increasing. They come on, right? Here, increasing, right? Then for a value greater than 0, right? Tell me an integer value. +1, no?
Plus 1.
If you put +1 here, minus, that means the function is decreasing, right? Actually, here after you can use only one, clear? Decreasing, right? That means increase in range, right? Therefore, y is increasing, right? Increasing, right? For all x reals, right? For all x real, x lesser than 0, right? Then y is decreasing, right? Decreasing for all x real, right? For all x real, x greater than 0, right? You can find out the values of x like this. It's a very simple idea. Clear, right? Okay, now please take it. Is the first one. Now, you have done enough questions by inequalities. This also something like that. I think second part is okay, right? Raise your hand those who have found that increasing and decreasing ranges quickly. Yes. Forward pass. What is the increasing range? 4x greater than 2. Senal, what is your answer?
Yes, sir. Yes, sir.
Yes, sir.
4x greater than 2, right? 4x lesser than 2, the function is decreasing. Yeah, that's what you can see, right? Okay, if I go to the third example, right, you know that y equals 12x minus x cubed. Then when you get dy by dx, you will be having 12 minus 3x square. Clear? Actually, when you have, you better write like this. 3 into 4 minus x square. Clear? Not only that, right? Can you remember that solving inequalities techniques? You know that no, if you want to solve an inequality, we have to write the expression with fully factorized form, right? So one factor is 2 minus x, other one is 2 plus 6, right? Write down that dy by dx up to maximum factorized form. Clear? That's the way, right? Then at station points, dy by dx equals 0. That means this is equal to 0, right? Therefore, 3 into 2 minus x into 2 plus x equals 0, right? That means x equals 2 or x equals minus 2, okay, right? Then what do we do actually? You can take x lesser than minus 2, between minus 2 and actually plus 2, and greater than 2, right? These are the ranges, right? Then here dy by dx, right? Now, please suggest an x value lesser than minus 2. If you put minus 3, where do we put minus 3? Here, right? Then 2 minus minus 3 means actually here plus, but they are minus. You get minus. The function is decreasing. The function is decreasing, right? In between minus 2 and plus 2, if you put 0, plus, plus, actually you get plus into plus as plus, right? The function is increasing in that range. If you put a value greater than 2, suppose that 3, then here minus into plus, you get minus. The function is decreasing. Clear? Then you can say that y is increasing in the range of, right, 1. All x real from minus 2 to plus 2. Clear? Then function is decreasing actually for all x lesser than minus 2 or greater than plus 2. Okay. Just like we are solving inequalities, right? Actually, that's why those days we solve inequalities to apply in these questions. Clear? Simple, right? Okay, now I got extra 5 minutes, right? And anyway, right? Not only 5 minutes, but copy down, right? Copy down this, right? I'll give another 5 minutes from the other side, right? So you can start at 6:05, right? Now we are there. First copy down this one, all right? Then get ready for equilibrium of a particle first. Okay, take your break. Right. Aditya, can you hear me? Manet, can you hear me?
Sir.
Right. Okay. Then write down the topic, the main topic, equilibrium. 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 Under that, write down another subtopic. Our main topic is equilibrium. Yes, actually you can continue, right? You can continue equilibrium also with the coplanar forces notebook, right? It doesn't matter because all are under statics, clear, right? If you have enough space, right, you can use that book for your equilibrium part also, right? Equilibrium. Then write down equilibrium of a particle. Equilibrium of a particle. Equilibrium of a particle. You know that particle means actually just a point, no? Right? Subtopic, equilibrium of a particle. Equilibrium of a particle. Equilibrium of a particle. Right now, actually, we have one exercise related to that equilibrium of particle also, right? The same coplanar forces tube, right? But our main part, equilibrium of a rigid body, right? Then you will be given a different tube for that, right? Right now, understand carefully. You know that when we go for this applied mathematics, right? In applieds, we have statics and dynamics, right? The chapter what you learn, right? The coplanar forces. Yeah, some parts of this coplanar forces will be applicable in dynamics also. Clear, right? Some parts of this one applicable in dynamics, right? But most of the parts, right, are applicable in statics itself, right? Then in statics, right, we have equilibrium of a particle, equilibrium of a rigid body, right? Actually, equilibrium of a rigid body means there are some different chapters, right? In that chapters also, the main topic is equilibrium of a rigid body. Now, as an example, smooth hinges, Bose notation, clear, right? Then center of gravity and applications, right? Center of gravity and application is actually application mainly equilibrium of a rigid body, right? So these are the chapters in statics, right? Now, all the questions will be easy, right? Now, if you are okay with this basic idea, right? Again, then අපි කතා කරේ coplanar forces එකත් එක්කම related ඊළඟ base chapter එක තමයි equilibrium of a rigid body, right? Because in this part we have a lot to study, clear, right? You learn this part means, right? Smooth hinges will be nothing. Bose notation will be nothing. That is the easiest, right? Then center of gravity also will be that much easy, clear? Right. Then now when you go for that equilibrium of a particle, you know that particle definition, right? Yes. Chandiru, can you tell me what is the definition of a particle? What is the definition of a particle? Chanul, tell me what is the definition of a particle? Yeah, again. Yeah, a dimensionless mass, right? The mass which has no dimensions is called, right? A point mass with no volume, right? Yeah, right. It also okay, right? A mass which has no dimensions is called a particle, right? ඇතරම මේ වෙනකොට සමහර ස්කූල්ස් වල ටර්ම් ටෙස්ට් තිබ්බා. මේ කවිෂ් ටර්ම් ටෙස්ට් තිබ්බා නේද?
Oh, sir.
There were 25 questions, right?
Yes, sir.
How is it? Okay.
Considering the time, sir, it was a bit too much, but managed 23.
Mhm. Right. Managed 23, but you are given 25, right?
Yes, sir.
Yeah, right. Anyway, do you have that soft copy?
Yes, sir. I do.
You can put that to the group also, right?
Okay, sir.
Right. It will be supportive, right? Thanks in advance, Kavish, right? Anyway, actually, there are most of the questions are something like, right, short questions, right? That is not the format in the examination, but anyway, conducting a particular test like that also better, right? You also please try to write your answers, right? And if you wanted to, if you wanted to get done the corrections, or that means marks, right? You can put into the upload through the previous link given, right? එමුණත් අපිට ඕන discussion එකකට යන්නත් පුළුවන්. හැබැයි සමහර questions ඇත්තටම තමයි එච්චර අවුලක් නැහැ, easily manage කරගන්න පුළුවන් ඒවා, right? I got the single medium paper, right? Yeah, that's the thing, right? Now, anyway, now come back to this one, right? Now, actually, in some schools, right, you may have already, right, if you had a term test, right, then sometimes you may have taken some questions by this equilibrium of particles. And not only that, right, you learn this equilibrium particle in physics also. Clear? එතන මේ මුලින් කතා කරන දේවල් පොඩ්ඩක් දන්න දේවල් වගේ තියෙනවා. හරිද? හැබැයි එතනින් තමයි ස්මූත්ලි අපි නොදන්න දැනට යන්න ඕනේ. හරි? එහෙනම් please concentrate and understand carefully, right? We have to take this all the concepts, right, part by part carefully. Okay, right. Now you know that if you take a particle, right, we can consider, right, equilibrium of particle first under the action of a, can't say single force, because if there's a force on this particle, right, if there's a force on this particle, if there's a single force means definitely there's a resultant, right? If there's a single force in this particle, right, with respect to this earth frame, right, right, if there's a force acting on this particle with respect to this earth frame, right, not with respect to a particular object which is falling under gravity. Clear? Right? මේ වගේ තෝරනම් කෙනෙකුට force එකක් apply කරන්න පුළුවන්. එතෙන්දි වෙන nature එකයි මේකයි වෙනස්. Right? Right? Now anyway, if there's a particle in this earth frame, if there's a single force, what will happen? What will happen? If there's a single force, right, on this particle with respect to this earth frame, what will happen? Yeah, it will accelerate. Good, right? It will accelerate. It will move. Right? Oh, move right? It will accelerate, right? Yeah, it will accelerate. Who said that? Who said that if there's a force on the particle, it will accelerate? Firstly, right? මට කලින් එයා දැකලා හරි මේක පොඩක් දේවල් තියෙන අපිට කලින් දැකපුවා ඉන්නවා හරි එහෙනම් මේ එයා ඒ නේචර් එකක් අපිට කලින් දැකලා හරි yeah, right, he said Sir Newton, right, yeah, then right, yeah, ඒ විතරනේ ගොඩක් තව දේවල් දැකලා තියෙනවා mechanics ගැන හරි අපිට ගොඩක් chapters තියෙනවා, right? Yes, because he born before us, right? Right, he observed these things anyway, right? is an extraordinary character, right? And condemn කරන්න දෙයක් හරි. හැබැයි දන්නේ නැහැ ඉතින් අපේ සමහර ගෝලියෝ right ඊටත් වඩා ගොඩක් දේවල් දකින්න තිබුණා. හරි. right තවත් ගොඩක් දේවල් ඔයගොල්ලන්ට දකින්න තියෙන නෑ ඉස්සරහට. හරිද? එහෙනම් ඔය basics idea ටික ගත්තාම තව අලුත් දේවල් වලට පෙනේ. හරි. Right. But anyway, now understand, right? This will accelerate with respect to an inertial frame, right? In the Newton ඊට කලින් යාගේ first law එකේ කියලා තියෙනවානේ inertia එක ගැන. හරි. I will discuss under the relative velocity, relative acceleration, right? About this frame of inertia and their applications nicely, right? But until then, right, it will accelerate if there's a single force, right? Now, if there are two forces only, we have to talk. See, right, in as usual, right? We have to talk with two, right? You know that if there are two forces, right? If that both were directed to the same side, right? Then again, it will accelerate with more than a single force, right? But if there are two forces, right, acting on a particle in opposite directions, right? In opposite directions, right? I take like this. Now, if there are magnitudes, clear, right? If there are magnitudes, what do I mention by this letter? Letter says the magnitude, arrow says the direction, right? If there are two forces acting on the particle, right, in opposite direction, then automatically the line of action of the two forces will be collinear. Clear? Line of action of the two forces will be collinear, right? Now understand, a particle will be in equilibrium under the action of two coplanar forces, right? If the magnitude of the two forces are equal, right, and opposite in direction, right? Because if it is opposite in direction, then definitely on the same line of action. Clear, right? That's the thing, right? Actually, we don't need to discuss much under the action of two forces, right? I said, Yusuf, aapku gawang mute karaganna I say. Right, okay, now I will just put two letters P and Q. Api ඕන forces එකක් කියලා ගමු. හරිද? Right, but you know that definitely magnitude of P should equal to magnitude of Q. Clear? That's the first thing, right? Okay, now that's not the thing that we have to discuss, right? The most important part, equilibrium of a particle under the action of three coplanar forces, right? Anyway, then write down first under the equilibrium of particle, right? Under that also you can put a stand, write down equilibrium of a particle under the action of two forces. Equilibrium of a particle under the action of two forces. Then a complete note එකක් ඕනේ තමයි මේකත් add කරන්න, right? Equilibrium of a particle under the action of two forces. Okay, then write down. Consider two forces of magnitude P and Q. Consider two forces. Okay, two forces P and Q, right? Consider two forces P and Q. Consider two forces P and Q. Act on a particle. Act on a particle A. Act on a particle A as follows. Take this part quickly because our next part is the most important thing, right? Consider two forces P and Q act on a particle A as follows, right? Okay, then please take this rough sketch quickly. And don't write this part, right? Only this one. Okay, then write down the particle A is in equilibrium. The particle A is in equilibrium, the particle A is in equilibrium if the particle A is in equilibrium, if the magnitudes of the two forces P and Q are the same, if the magnitudes of the two forces P and Q are the same, and if the magnitude of the two forces P and Q are the same. Actually, within bracket, please mark this part, right? Magnitude of P equals magnitude of Q. And opposite in direction. And opposite in direction. If the magnitude of the two forces are the same and opposite in direction. Right, okay, then write down next part. Now, this is the most important point, right? Equilibrium of a particle under the action of three coplanar forces. Put a stand right down. Equilibrium of a particle under the action of three coplanar forces. Equilibrium of a particle under the action of three coplanar forces. Three coplanar forces. Right. The මේක නම් ළමයි කෙලින්ම මේ idea එක එකටම ගන්න ඕන. හරි. එහෙනම් මම ඉස්සෙල්ලාම පොඩි activities ටිකක් දෙනවා. හරි. Let's see how do we manage this, right? Okay, now suppose that there's a particle here, right? Then there are three coplanar forces like this, right? Yes. Now this angle is actually 45 degrees, right? Now this is actually 10 newtons, right? And this also 10 newtons, right? And this is 10 root 2 newtons. Okay. 10 root 2 newtons. Understand carefully. This is just a picture. Again, the point mark කරලා ඔන්න forces තුනක්, right? Act වෙන හැටි අපි mark කරලා තියෙනවා. This is just a picture, right? You can solve, right, problems under the equilibrium of a particle or with the three forces, right? Three coplanar in the single plane, right? Three coplanar forces, right? By three different methods, right? Actually, one is the force triangle, right? Other one is the Lami's theorem, right? And the third one is what? Taking components in two perpendicular directions, right? I think you have used this all three methods in physics. Have learned? If you learn, please raise your hand. All three methods. Are you learning that Lami's theorem now? Is it there in the syllabus? Physics. Not Lamy. Just mention. Okay. Who are the ones learn only by that force triangle? Who are the ones who learn by components? Components in two perpendicular directions. I see. Right, okay. Anyway, right. Now, there are three coplanar forces, right? Now, shall we check whether the particle is in equilibrium or not? Now, actually, we can represent this one in a scale drawing, right? What do? Right? We are going to draw a particular diagram under these forces. That means, actually, these forces are going to be actually, right, represented by a scale drawing, right? What does it mean? Okay, right. I'll take this 10 newtons, right? So suppose that 5 Newton equals 1 centimeter, right? 5 newtons equals 1 centimeter. What does it mean? All right, now you can represent this first force, right? Actually, you can start with any force because all are known, right? Then if you represent 10 newtons by 2 centimeters, what is the length of this side AB? What is the length of side AB, Mohammed?
2 centimeters.
Okay. Then if you take this 10 newtons, right? Actually, second force will start from the end point of the first force, right? That means actually 10 newtons this way. That means understand that this length is 2 centimeters. Okay. I take this point as C, right? Then the third force this way. Okay? Now, if this is 2 centimeters, right? If this is 2 centimeters, right? Yeah, I just connected these 2 points A and B. Can someone tell me what is the length of the side AC? What is the length of the side AC in centimeters? You know that here 90, right? So these two are equal. That means 2 square plus 2 square. Square root means 2 root 2, right? 2 root 2 centimeters. Now you know that 1 centimeter is 5 Newton. That means actually 2 root 2 into 1 centimeter. So 2 root 2 into actually 5 Newton, right? That means you get 10 root 2 Newtons, right? Now that means this force also 10 root 2. Accordingly, you can see that actually this particle is in equilibrium under the action of these three coplanar forces. Right? Okay, now let's do this first activity, right? Okay, now write down. Three coplanar forces act on a particle A as follows. Three coplanar forces act on a particle A as follows. Three coplanar forces act on a particle A as follows. State whether the particle is in equilibrium or not. State whether the particle is in equilibrium or not using a force triangle. State whether the particle is in equilibrium or not using a force triangle. Yeah, I think you can read out this part. The magnitude of the force by AC is 10 root 2 Newton. And other මතක තියාගන්න අපි අඳින්නේ scale drawing එකක්. හරි. මෙහෙම ඉතින් හරියටම මැන අඳින්නේ right. අපිට trigonometry තියෙන හින්දා geometric knowledge එක තියෙන හින්දා අපිට එකක්වත් scale එකට ඕනේ නැහැ. right. Scale එකට වඩා accuracy value එකක් අපිට ගන්න පුළුවන්. හරි. But anyway, then take the corresponding force triangle Actually, this is the force triangle, right? Right, Dulaj, finish up to this.
Yes, sir.
Right, okay. Then write down the next example. The particle A is equilibrium. The particle A is in equilibrium. The particle A is in equilibrium. The particle A is in equilibrium under the action of the three coplanar forces. Under the action of the three coplanar forces given below. Under the action of the three coplanar forces given below. Find the magnitude of the force F. Find the magnitude of the force F. F just says a letter, so we want to find out the magnitude of F, right? Find the magnitude of the force F. Now, I will just mention this angle as theta, right? Okay, first, represent this one in a scale drawing. What do I expect by a scale drawing? What do I mean by scale drawing? So you have to draw force triangle for these forces. Clear? Okay. See how do we draw it? Actually, you know that here magnitude direction both are known. Direction downward, no. Then here magnitude direction both are known. But here magnitude direction both are unknown, right? How do we do? By which force you can start? Actually, you can start by either 20 newtons or 20 root 3, doesn't matter. Clear? Now, shall I start by this 20 newton? So you can mark 20 newtons this way. Clear? A, B. Now understand, suppose that 10 newtons is 1 centimeter, right? Now here, this is by 2 centimeters, clear? Then 20 root 3, right? Then there will be a side like this, clear? So this is the point C. It says that the particle is in equilibrium, then definitely the resulting force, that means third force, should come to this point, clear? So you know that this is 2 centimeters, this is 2 root 3 centimeters, here, right? Here 2 centimeters according to that dimensions. 2√3 centimeters, right? Now here 90, right? This angle theta unknown, right? So shall we find out this length? How can you find out this? We already know that, right? This is a right angle triangle, right? Angelo Vishwakula. Angelo Wilfred or Vishwakula? Who are you now? Right. Then now you know that this is a right angle triangle, right? So therefore, you can find the length AC easily, right? Because again, AC equals what? 2 squared plus 2√3 squared square root means 4 centimeters, right? Therefore, right, magnitude of the force by AC equals 4 into 10, you get 40 newtons. Clear? How can you find out this theta? Now, we can apply simple geometry, right? That means, you know that tan theta equals 2 over 2√3, right? Then 1√3 means actually, you can see that theta equals 30 degrees, otherwise pi by 6 radians, clear, right? Whatever, etc. Clear? So we found the magnitude of F and the direction. So that means we found the force F. Clear? Okay, now please take. Third example. Okay, now here find out that F and theta. When you have 3 coplanar forces like this should be done by a force triangle, okay? Okay, now we can start by this known magnitude and direction, right? So how do we represent 10 newtons this way, right? I take AB, right? Then may AB represent magnitude, right? So I will mark directly 10 newtons. Okay. May length and display 10 newtons. Then scale Darwin or 5 newtons 1 centimeter, 2 newtons 1 centimeter scale right? We discussed 3 examples. Okay. Then how do you start the next one? Actually 30 degrees with this, right? So you can draw a line like this. This angle is 30 degrees. Clear? We don't know where's the end point, right? But actually there must be, right, a line like this which is parallel to this one. Okay? So understand that, right? This angle is theta. Okay? That angle is theta, right? Then yeah, then this is 12 and this is F. Okay? That is F. Then how do you solve for this theta and F? So you know that this is theta means this is 90 minus theta. Right? ABC. ABC. Understand that this is a scale drawing that is called a forced triangle. Okay? Right. How do we take this? Trigonometry study කරපු ඒවා ඕන. හරි. That means especially sine rule, right? You know that by sine rule, what can we do? By sine rule, right? Now you know that this is a triangle. We know this length is 12 newtons. This is 10 newtons. Clear? Then you can write actually 12 over sine 90 minus theta. Okay? Equals 10 over sine what 30 plus theta, no? And which is equals to f over sine. This angle 30 means actually you know that this angle is 60, right? F over sine 60. Okay? F over sine 60, right? So there are two unknowns. One is theta, other one is f. Clear? Shall we find theta first? Now by equating, right? 12 over sine 90 minus theta means actually cos theta equals 10 over sine 30 plus theta. Sine 30 plus theta, right? Then 2 into 6, 2 into 5. Then please help me to simplify. That means actually 6 into sine 30 plus theta. How do we solve this? How do we write actually? Sine A plus B expansion. Sine 30 plus theta means sine 30 cos theta plus cos 30 sine theta, right? Which is equals to 5 cos theta. Clear? 5 cos theta. Okay. Now, how do we find out this angle actually? You know that sine 30 is half, cos 30 is root 3 over 2. This, here root 3, here 3. Can you understand? Sine 30 means half, no? Then cos 30 is root 3 over 2, no? 2 cancel with this 6, right? Then you can see that 3 cos theta plus 3 root 3 sine theta, right? 3 root 3 sine theta equals actually 5 cos theta, right? That means 2 cos theta, this goes to other side, equals, right? 3 root 3 sine theta. Okay. Now cos theta goes other side, then tan theta equals actually 2 over 3 root 3. That means theta equals tan inverse 2 over, right? 3 root 3. Can you understand? We found the angle, right? Tan theta is 2 over 3 root 3 means, you know that here theta, this is 2, this is 3 root 3 means actually, what is 3 root 3 square? 9 into 3, 27, no? 27 and 4, 31. Then this will be root 31. Clear? Then very simple, right? Therefore, actually cos theta equals how much? Cos theta equals actually 3 root 3 over root 31. Clear? Now, shall we equate these two? Then by, right, by 12 over cos theta equals f over sine 60, right? F over sine 60. So I don't have space there, I will write here. Therefore, f equals 12 sine 60 divided by cos theta, right? That means 12 into sine 60 is what? Root 3 over 2, right? Divided by cos theta means actually 3 root 3 and multiplying by root 31. Okay? Multiplying by root 31. What happened? Root 3 cancel. 3 into 6 cancel with this. You get 2. Then final answer is 2 root 31 newtons. Clear? අපිට problem solve කරන්න ඔය කාර්යවත් techniques ඕනේ හරි අපිට ඕන solving triangles techniques විතරයි හරි if you are okay with the sine rule and cos rule right you can solve a lot in this world under mechanics clear right anyway right anyway right first take this part right and I'll discuss another example. Then after that, we can generalize a good theory, right? Fourth triangle is a subset of triangular law. Yes. Fourth triangle is a subset of triangular law. Yeah, if you are talking with that set notations and words, it's okay, right? That means triangular, yeah, triangular, that means yeah, doesn't matter, consider like that, right? But here, actually, it's not exactly that, because see, here all the arrows are in this way. This arrow this way, this arrow this way, this arrow this way, right? Finally, end point and starting point should be coincident. In the triangular law, you know that if you have something like this, one arrow this way, this is the resultant here, right? So therefore, here resultant is 0, right? That's the difference, right? Okay, then I'll take the last example. Please try to take this by yourself, right? Next example. There's a force this way, right? And there's another force this way, right? And there's another force this way. Actually, this angle is 60 degrees, right? This angle is 60 degrees, right? And this way F newtons, right? With this angle theta, right? So here 12 newtons. This way 18 newtons, right? And this is F newtons. Please represent them in a force triangle. In your term test also, you are getting same way like these questions, right? Then what do? We can represent them in a force triangle, right? That means 12 newtons this way. This way 12 newtons, right? And then 60 degrees. This way, like this. This angle is 60 degrees, right? Now understand, when you have a line of action like this, the corresponding line in the scale drawing should be parallel to this line. This line should be parallel to this one, right? Then 60 degrees, and this line should parallel to that one, right? So something like this. Then again, this angle is theta. This is 90 minus theta, right? So this way 18, this way F, okay. 12, 18, F. This angle is 30. Now, by sine rule for the triangle ABC, right? by sine rule for the triangle ABC. What does mean sine rule? You know that 18 over sine 90 minus theta, right? 18 over sine 90 minus theta equals 12 over sine 60 plus theta, right? And equals f over sine 30. Right, first equate these two and tell me what is sine theta. So tell me what is theta, right? 12 over cos theta equals, sorry, 18 over cos theta equals 12 over sine 60 plus theta, right? Then cross multiply, then go to the expansion of sine 60 plus theta. Then by 18 over cos theta equals 12 over sine 60 plus theta, right? 6 into 2, 6 into 3, right? Then 3 into sine 60 cos theta plus cos 60 sine theta equals 2 cos theta. Then what happened? You know that here 3 into 3 over 2 cos theta plus half sine theta equals 2 cos theta, right? Multiply on this side. 3√3 cos theta plus 3 sine theta equals 4 cos theta, right? Then this. What is the large value of that 4 and 3√3? This is an obtuse and they can't be. The situation is impossible because theta may be an obtuse angle. In the back. Yeah. Can you take this as 24 newtons? Please take this as 24 newtons. Then here 24. Here 24. Then here 24. Then 6 into 3 and 6 into 4. Then here 4 cos theta. Please make this correction. Right, this must be 24. Then here 4. And 4 into 2 here 8. Now it's okay. Then you can see that 8 minus 3√3 cos theta equals 3 sin theta, right? Then you'll be having tan theta, right? Tan theta equals 8 minus 3 root 3 divided by 3. Tan theta known means theta is known. Okay. Then put in a triangle and take these values. Here 8 minus 3 root 3. And this is 3. Tell me what is L? L squared equals 8 minus 3 root 3 squared plus 3 squared. 64 and 27. 27 and 9. 36. 36 and 64 means 100. L squared equals 100 minus 48 root 3. And this L equals all the multiples of 4. 4 means actually then 2 into 25 minus 12 root 3. L known means therefore cos theta. Cos theta equals 3 over 2 root that thing, right? මේ මම ලියන්නම් 2k කියලා. හරි. k කියන්නේ මෙන්න මේ වැලියු එක. මේ හැම එකක්ම ළමයි papers හදනකොට හිතන දේවල් නේ. The example එකක් විදිහට 2009 question එකේ right ඔය වගේ irrational numbers ආපු ගමන් ඒගොල්ලෝ k කියලා වැලියු එකක් දාලා තියෙනවා. Finally, let's take this as k and show that the answer in terms of k, right? So you know k means root of this answer. Okay? Then you can write here 2k. Cos theta is 3 over 2k, right? Understand k is 25 minus 12 root 3. ඔය වගේ අපත values ආපු ගමන් ඒවට k කියලා දාන්න. හරි. k කියලා දාන්න වෙන මොකුත් වැරදි වචනයක් අදහස් කරලා නෙවෙයි. හරි. But you can put like that, right? 3 over 2k. Right. Now you know if because equate this and this, you can take f. Then by f over sine 30 means half equals 18 over cos theta. Cos theta is 3 over 2k. And do 2 cancel. Then you can have s, right? That's the way. Now, can you represent any 3 forces in the force triangle? Mainly what I wanted, representing 3 forces in the force triangle. Okay? And right, making confidence to solve the questions by the triangles, right? If you have anything with the triangles, we can solve by using sine and cos rule, right? That's what I wanted to show by this, right? What is the value of f then? Idura? Let's simplify. 3 over 2k, 2 to cancel.
6k.
6 over k, right? No. 6K, ne?
So 6K.
6K, right? F is 6K. That's how we get the forces, right? All right. Now see whether you can manage this one or not. If so, that's great. Right. Then write down. Consider three forces of magnitude. Consider three forces of magnitude. Consider three forces of magnitude. PQR. Consider three forces of magnitude PQR. Consider three forces of magnitude PQR. Act on a particle A as follows. Act on a particle A as follows. Now, in this case, there's a small difference actually, right? We don't know the angle to the horizontal. We know only the total angle. Clear? We know only the total angle, right? Okay, then act on a particle A as follows. Then write down. Alpha, comma, beta, and gamma. Alpha, beta, and gamma are the angles between lines of action of two forces. Alpha, comma, beta, and gamma are the angles of line of actions of the three forces. දැන් මෙතන කේස් එකේ ඔක්කොම දන්නවා magnitudes. හරි. PQR දන්නවා, alpha beta gamma දන්නවා. හරි. So we are going to take one important result, right? Sometimes you may know what we are going to do, right? යන්න බලමු. හරි. Okay, now you know that this is just a picture, no? Right? It's a picture, right? So we want to convert this to a forced triangle. That means we have to represent this by a forced triangle. Clear? Then what do we do? You know that the first force is P. Right? P. Clear? Now I'll mark this by A and this by B. Right? The second force is Q, right? Actually, direction this way. So you can draw a line parallel to that one through this way. That's the line of action of Q, right? The line of action of R that way. So you can draw a parallel line like this here. Parallel line to that, right? I'll take this point as C. Right? So you know that this is the force P, right? And this is the force Q, right? And this is the force R, okay? Now, see whether you can remember that vectors and their theory or not? Especially, you know that angle between two vectors, right? How did you define angle between two vectors? Tell me, Milani. How do we define that angle between two vectors? Goes to a point or away from a point. Very good, right? To the point or away from the point, right? Yes, Akash, good, right? You know that here this arrow from this point, this arrow this way, that means outside of the point. So this arrow towards the point, that means actually here inward, this is outward. So if so, this is not the angle between two forces. Clear? Now you know that angle between the two forces P and Q here, angle between the two forces P and Q here, gamma, right? What is that gamma? This is that particular angle gamma. Okay. If it is gamma, what is this angle? You know that pi minus gamma. Okay? Pi minus gamma. Now again, the angle between Q and R. Q and R is alpha, right? Actually, this way Q, this way R. This angle is alpha. Clear? And the angle between R and P, right? R is this way, P this way. This angle only beta. Okay. If so, this is pi minus beta. This angle pi minus gamma. Clear? You know that our geometric triangle is ABC. These are the internal angles. We don't want that external angles. So that's why we found these internal angles. Clear? Then, you know that especially this is a scale drawing. That length says the magnitude of the force Q. This P says the magnitude of the force. Actually, this length says the magnitude of the force P, and this CA length represent the magnitude of the force R. Clear? Then you know that actually by sine rule, right? By sine rule for the triangle, right? For the triangle ABC. Please tell me, how do we write? P over sine pi minus alpha, right? Pi minus alpha equals Q over sine pi minus beta, right? Pi minus beta equals R over sine pi minus gamma. Clear? Now, if alpha is an acute angle, what is pi minus alpha? Right? An angle in the second quadrant. Even in the second quadrant, also sine is positive. So tell me, what is sine pi minus alpha quickly? What is sine pi minus alpha? What is sine pi minus alpha? Charita, what is sine pi minus alpha?
Sine alpha.
What is the reason behind that? Why is that?
It's in the second quadrant. It's in the second quadrant. So sine is positive, and
Yeah.
pi minus means it doesn't change the ratio.
Okay, because of an even multiple of pi by 2, right? Right, good. Then Q over sine beta equals R over sine gamma, right? Actually, this is an you know that not equality, right? Equal in L2 quantities, you can find out any other unknown, right? If you know this one, if you know this one, if you know this one, you can find this one. If you know this one, if you know this one, if you know this one, you can find this one. Clear? That means an equation, right? So this is a particular relation. Relation means also a kind of an equation, right? Actually, we got this particular result. This result is called what? What is this result called? What is this result called? Lamis theorem. Clear, right? That is called the Lamis theorem, right? So the Lamis theorem, right? Okay, Namadaganda tana logo siddhiya nevi, right? Come on, name. Mahindra Rajapaksa vidangane කියලා තියෙන්නේ. මහින්ද රාජපක්ෂ දැන් සමහරවිට ටොයිලට් කියලා තියෙන සමහර නම් වල. හරි. ඒ හින්දා අවුලක් නැහැ ළමයි. හරි. But anyway, right, you can see that it's a very small result by the sine rule. The main theory is what sine rule that what we learn. Right? තමයි ලාමීස් කරන්නේ පොඩි editing එකක් අතන. හරි. පොඩ්ඩක් edit කරලා නම දාන්න. හරි. right, ඒ වගේ කට්ටිය මේ society එකේ ඕන තරම් ඉන්නවා. Right? But by this hereafter actually you can see that we no need to go for the geometric constructions, right? That is the advantage, right? Now you know that no? In all the previous questions, we made the geometric construction, right? Because we want to draw the first angle, right? But here you can skip this technique and then we can go directly to that one. Clear, right? So that's the advantage, okay? Right, so how do we take that? P divided by sine alpha equals Q divided by sine beta equals R divided by sine gamma, clear? But it is proved by the sine rule, clear? Okay, now please take this result. Right, okay, then write down. I think you have finished it. Arkam Abdullah, finish?
Yes, sir.
And you are not in the first session, right?
Yes, sir. There was a power cut.
Okay, then write down. This is called the Lamis theorem. This is called the Lamis theorem. This is called the Lamis theorem. Right, okay, then we can go for the applications of this Lamis theorem, right? There are very simple questions. Now please go to the coplanar forces tuned. The video is stopped, right? Now, ඉදුර දැන් ඕකේනේ පේනවනේ. What happened here?
සර් ලොකු වෙලා තියෙන දැන්.
මොකද්ද?
නෑ සර් zoom වෙලා.
ආ.
දැන් total board එක වෙන්නේ.
ආරවැඩේ. What's this? Mhm. There's a small technical issue, Buddha. Uh, Kavish, දැනට පොඩි ඒරියා එකක් පේනවද?
මේ තමන් ෆොටෝ එකක් කියන්න පේන ටික.
අන්න පේන ඒරියා එක මට හිතා ගන්න පුළුවන් dimensions. පොඩි ඒරියා එකක් පේන්නේ නේ.
ඔව් සර්.
This is the original range. HD දුන්න. Right. Now okay, right, Kavish?
Okay, sir.
Right, okay. Then now please go to the tute, right? In the tute, page number 7, right? The page number 7. The page number 7. Question number 18, right? So they ask it under this data, right? There's a 30 kg weight, right? You know that 30 kg mass, its weight is 30 G, right? Then find the tension in the strings OA and OB shown in the diagram, right? OA and OB shown in the diagram, right? Actually, this is not a big question, it's a very simple idea, right? Okay, now just take that diagram to your note.
So what's the question?
Question number 18 in the page number 7. Page number 7, question number 18. Now, there's a horizontal string, right, with the tension T2, magnitude is T2, right? Here 30 G, right? 30 G newtons, right? And this is T1, okay? This is T1. So you know that actually this angle is, right? This angle is 60 degrees, right? That is 60 means actually this is 180 minus 60. If you could write like this, it will be easy. Here, anyway, here 90, right? Now you know that here 90 plus 60, right? Total angle is 90 plus 60, okay? Total angle. Now I will solve this one by a few methods, right? Method 1 by Lami's theorem, right? By Lami's theorem, you know that here T1 over sine 90 equals T2 over sine 90 plus 60, right, equals 30g over sine 180 minus 60. Okay, we can write like this. Got it? Then, actually, if you equate, right, if you equate this and this, you can find T1, right? Then by T1 over sine 91, then 30g over here sine 60, right? Sine 60 is root 3 over 2, no? Right? Therefore, T1 equals actually, you know that here 30 means 3 into 10g divided by root 3 into 2. Clear? Then what happened here? Root 3. Then T1 will be 20 root 3 g newtons. Okay. This is the value of T1. Okay. Now we can go for the we want to find out both T1 and T2, right? Then by T2 over sine 90 plus 60. What is that? Cos 60, right? Sine 90 plus 60 is cos 60 equals 30g over, you know that sine 60 is root 3 over 2, right? Then here cos 60 means half, that time this will cancel, right? Therefore, T2 will be actually 10 root 3g, right? These are the values of T1 and T2, clear, right? Okay, now it's a very simple question, right? So we have solved by Lami's theorem, right? Then method 2, right? By resolving components, right? So you know that by horizontal components equate into 0, right? By horizontal components equate into 0, you will be having, right? Then T2 minus T1, right? T2 minus T1 cos 60 equals 0, right? Then cos 60 is half, no? Therefore, actually T1 equals 2T2. Yeah? T1 equals 2T2, right? Then by vertical components equating to 0, you will be having T1 cos 30 because this angle is 30 degrees, right? T1 cos 30 minus 30g, right, equals 0. Cos 30 is root 3 over 2. So T1 equals actually 30g into 2 over root 3, right? Here T1 is actually 20 root 3g newtons. Okay? Therefore, T2 can take by this one quickly. T2 is T1 over 2. Then you will be having actually right 20 root 3g divided by 2. That means 10 root 3g newtons. Okay? This is how we can take by the components. Components are efficient, right? So you can take the answers quickly. Clear? Anyway, right? Take these things. Then after this, please read the question number 90, right? Now, I suggest you to do that 19th question completely by the Lami's theorem. Clear? Try to take this answer by the Lami's theorem only, right? Then situation එක ලේසි නෑ පුතේ. දවසකට 94 deaths, right? මම හිතුවේ ඔය යන nature එකේ හැටියට next week වෙනකොට 100 reach කරයි කියලා. හරි. ඔය ඉතින් ගොඩක් වෙලාවට 94 කියලා කියන්නේ, right? ගන්නකො ලංකාවේ per day 100 කියලා කියන්නේ ඉන්දියාවත් එක්ක compare කරපුවම සෑහෙන dangerous. හරි. And සමහර මිනිස්සු සෑහෙන confidence දැන් vaccine එක ගත්ත කියලා corona දුවනවා කියලා හිතාගෙන vaccine එක දැක්කම. attitudes රටක attitudes කියන ආදන් නැතුව ළමයි කිසි දෙයක් කරන්න බෑ. හරි. මේ රටේ පාලකයන්ට උවමනාවක් නැහැ මිනිස්සුගේ attitudes හදන්න. ගොඩක්ම 70ක් විතර මිනිස්සු ඉන්නේ මිත්‍යාව කියන එක පිටිපස්සේ. හරි. එහෙනම් ගොඩක් වෙලාවට ලංකාවේ මිනිස්සුන්ට කෙලින් කතා කරනවට වැඩිය අර පොඩි ළමයි නලවනවා වගේ බොරු වලින් තමයි ගොඩක් වෙලාවට රවට්ටන්නේ තියෙන්නේ. හරි. ඒ කොරෝනා කේස් එක වුණත් ඒ වගේ මොකක් හරි පත බොරු කතාවක් කියන හැදුවා නම් ළමයි මේ වෙනකොට මිනිස්සු මාර විදිහට කන්ට්‍රෝල්. හරි. තනුල් බාදලේ මොකද ප්‍රශ්නේ? මම දැන් highest COVID patients නේ. පරිස්සමෙන් හිටපන් පුතේ. ඒ විතරක් නෙවෙයි නම ඇත්තටම අපේ මේ තව sad story එකක් තියෙනවා අපේ වලගෙන ක්ලාස් එකේ වලගේ යාළුවෙක්ගේ තාත්තා කෙනෙක් අපේ ස්ටුඩන්ට් කෙනෙක් ඉන්නවා මාදේශ් කියලා. හරි. මාදේශ්ගේ තාත්තාට තිබුණේ නම් කැන්සර් එකක්. හරි. හැබැයි යා හොස්පිටල් එකේ ඉන්නේ නැද්දි කොහොමරි යාට කොවිඩ් ඉන්ෆෙක්ට් වෙලා තියෙනවා. හරි. ඒකත් එක්කලා මම තනියම තාත්තා නැති වෙලා තියෙනවා දැන්. දවස් කිහිපයකට කලින් මාදේශ් තාම ක්වොරන්ටයින් වෙනවා. හරි. ඉතින් එයාලා කියන්නේත් හොස්පිටල් එකේ ඉඳි තමයි එහෙම උනේ කියලා. හරි. ඒ ඉඳන් ඉතින් අතට ලොකු රිස්ක් එකක් තියෙනවා දැන් හොස්පිටල් එකේ පාව නැතිලා ඉන්නේ. හරි. මාදේශ් තැන් ගෙදරද? Fat negative. Rapid antigen ද? කවිෂ් PCR කරලා නැද්ද? Hmm. Right. Then, did you start the 19th question? Actually, in the 19th question, the string ABCD is attached to two fixed points A and D. It carries two weights, each W, right? Two weights, each W, right? At B and C. When the system is in equilibrium, the parts of the strings AB and CD make the angles 30 degrees and 60 degrees respectively with the vertical. Listen carefully, right? With the vertical. Find the angle made by the part of the string BC with the vertical and the tension in the string and the parts, three parts of the string, right? Now we are smoothly moving to, right, one important part. What is that? How do we get a diagram, right? By reading and taking the data. Clear? Applied questions were the main part. Please listen carefully, right? So you have to practice to read the question twice. This is not a novel, right? So there are actually you are given data by sentences, right? Understand that, right? They are trying to give by the minimum length of the sentence, right, with the maximum data. So you have to be careful to read out part by part, right? Then you have to have a rough sketch, and then you have to go for the proper diagram, right? Time by time, you have to practice to reduce the rough sketches. You have to try to take the answer by the proper diagram itself, right? In some cases, definitely we have to go for the rough sketches, right? So there's a lot to manage the question, right? Not just reading and answering. Clear, right? Now we are smoothly moving to those concepts also, right? In applied mathematics, right? Understand carefully. Reading and understanding and rough sketches and right analyzing is one important thing, right? Right now, read the question again, right? See what this data says, right? Now, actually, this is not the string, right? A and B are the two endpoints, okay? A and B. Now, it says the part AB, right? Like this, 30 degrees. Okay. And I don't know actually for the angle, I will just take like this and the other part like this. Okay. Wait. AB makes an angle 30 degrees with the 30 degrees and 60 degrees with the vertical, right? The diagram is not like this. Is like this. So this angle is 60 degrees, clear? And here the weight is W. and here the weight also W. Here B and here C. This angle 30 degrees, right? Now I will take this angle to the vertical is theta, right? Therefore, this angle is 30 degrees, right? So you know that this angle is actually 180 minus 30, right? And this angle also 180 minus theta, right? If this is theta, you know that this angle also theta because they are alternate angles. And this is 60 means this angle also 60. And this angle is 180 minus 60. Yeah. 180 minus 60, right? And so this is theta means actually this angle is 180 minus theta, right? So this is what you need to know, right? And please understand carefully. Stop your work, right? Stop your work and listen carefully, right? When you have different parts of the strings like this, right? Understand you are given that the weights are attached. That means fixed on the string, okay? Right? Not like a ring, clear? Actually, if you have a ring, right, both the rings will come to a single point and will stay in equilibrium. Now here the weights are fixed. If so, right? If so, each part of the string have different tensions. That means magnitude of the forces along the strings are different, right? So I will define this as T1, okay? And here T2, right? If so, this also T2, right? And this is T3, clear? This point is pulled, so therefore T3, but no need to mark them. We have to mark the forces outward from the point, clear? T2 like that, okay? First step, right, you should be actually here vertical line, it seems to be slant, right? That's a vertical line, okay? Now they expect to find out the angle theta and T1, T2, T3, right? How can you find out this T1, T2, T3 in terms of W and theta? You can use the Lami's theorem, right? Okay. By Lami's theorem, right? At B. You know that actually here T1 over sine 180 minus theta equals T1 over sine 180 minus theta equals T2 over sine 180 minus 30 equals W. W is given, right? You can leave the answer in terms of W. W or sine theta plus 30. Theta plus 30, right? That means actually, you know that T1 over sine theta equals T2 over sine 30 equals W over sine theta plus 30, right? Yes. Then at C, you know that T2 over sine 180 minus 60 equals T2 over sine 180 minus 60 equals T3 over sine theta equals, right, W over sine. Actually, this angle is one important thing, right? Understand carefully. How do we take this angle actually, right? If I take it as alpha, alpha is 180 minus theta plus 60. That means actually 180 minus theta minus 60, okay? right? We can write like that. So therefore, W over sine 180 minus theta minus 60. Okay. That means T2 over sine 60 equals T3 over sine theta equals W over sine theta minus 60. Okay. W sine theta minus 60. Right, then I'm not doing anything else, right? Third one, suggest how to solve this, right? Now you better equate T2 and W this one, then subject T2. Here you equate T2 and W and this thing, subject T2, right? Then equate them, you can find theta first, clear? Equate these two, right? And T2 is there. Equate these two, T2 is there, right? Then subject T2 and then equate the result in two terms. W will cancel and you will be able to find out theta, right? After finding theta, you can find all T1, T2, T3, right? I put that image to the group, right? The ones who found quickly, right? Please put into the group the correct answers, right? Then we discuss another, one or two questions under this, and then we are moving to that equilibrium of a rigid body. Clear, right? Okay, then get ready. Tomorrow we are doing few more questions by coplanar forces also, right? Yeah, okay, that's all for today. Good night, everyone.
Thank you, sir. Good night,
Thank you, sir. Good night.
Thank you, sir. Good night, sir.
Thank you, sir. Good night.
Thank you.
Thank you and good night, sir.
Sir, good night.
Thank you, sir. Good night, sir.
Thank you, sir. Good night.
Thank you, sir. Good night.
Thank you, sir. Good night.